Hello everyone. So in this segment, let's find the execution time of an algorithm if we have a simple if statement. So let's see here we have a simple if statement. So in this if statement, we can see that here we have a if condition. All right. So we know that if the if condition is true, then the if statement will be executed. Otherwise, the else statement will be executed. So this if condition will be always executed. And let's say this if condition has a runtime C1. Okay. So here it will check that whether the n value is less than 0. Okay. So it's a specific instruction, and it has a cost, a certain amount of time cost, which is constant C1. Okay, and times means how many times this instruction will be executed. So here you can see that it's a simple if statement. It will be executed only one time. All right. Now, depending on the truth value of this condition, either this statement or this statement will be executed. Okay. So now let's see what will be the total cost. So if this condition is true, okay, so this statement will be always executed. So C1. Now, if this condition is true, then this statement will be executed where the cost is C2. Okay, but if this is false, if this condition is false, then this statement will be executed where the cost is C3. All right, and you can see that each of the instruction is going to be executed only one time. All right, so here the total cost will be either C1 plus C2 or C1 plus C3. Okay, or we can express like this the total cost. We can say that total cost is not going to be greater than this value. Okay, so total cost is going to be less than or equal to C1 plus max C2 C3. All right, now we're going to see the execution time of an algorithm if we have a loop. So in that case, our execution time, calculation of execution time is going to get slightly interesting. Okay, all right. So here we have a simple loop. So you can see that first we're initializing the loop variable to 1. Then this sum is going to be used as the accumulator variable. Okay, so you can see that here we're actually calculating the summation of sum of series. So sum of 1 to 1 plus 2 plus 3 plus up to n. Okay, inclusively. So so sum we're going to initialize with 0. So you can see that it has a specific cost C1, it has a specific cost C2, and both of these instruction will be executed one time. All right, but then we are running a loop. So a loop means that the statement inside the loop body will be executed multiple times. All right, and how many times it will be executed depends on the condition, while condition. So our while condition is that if I is less than or equal to 0, if I is less than or equal to n, okay, then it will execute this set of statements. All right, so you can see that it will check whether I is less than or equal to n. All right, so whether I is or less than equal to n, this is a statement, and this statement has a specific cost. Let's say the cost is C3. Okay, but how many times this statement will be executed? Okay, so this statement will be executed n plus 1 times. All right, so last time, okay, so last time means n plus 1 time, okay, it will find this condition is false. Okay, our program will find this condition will be false and it will exit from the while loop. All right. Now, n time means for the n time, our condition will be true. All right. So these two lines, okay, these two lines will be executed n times. So here we have one instruction, I equals to I plus 1. We are updating the expression. We are updating our loop variable. Otherwise, it is going to create an infinite loop. Okay. So let's say this instruction has a fixed cost C4. Okay. But this loop, but this instruction will run n times. All right. And this instruction will also run n times. And it has a specific cost C5. All right. Now let's see what is the runtime of this algorithm. So C1 will run 1 times, C2 will run 1 times plus, now C3 will run n plus 1 times. Okay, so C4 will run n times and C5 will run n times. Okay, so that is our total cost. So you can see that our total cost is C1, C2, C3 n plus 1 times, C4 n times, C5 n times. All right. So let's actually simplify that from this. So you can see that C1 plus C2. Okay. So C3 times n plus C3 plus C4 times n plus C5 times n. Okay. Or we can say that now, as C1, C2, C3, C4, C5, all are constant. Okay. Now, if we add multiple constant values, they are still constant. So here we can express it like that: C1 plus C2 plus C3 C3. Okay. Then n times C3 plus C4 plus C5. All right. So this one is a constant, this one is a constant. So we can express it like that. Let's see, use just another constant value, say C6, all right, plus n times C7. Okay, so this one is constant, this one is constant. All right, so here you can see that C6, C7 both are constant, but n is not a constant. What is n here? N is actually the input size. Now here, if the n value is, let's say C6 is a fixed amount of time, let's say 1, okay, and C7 is 1, all right. And now if n equals to 10, our runtime will be like 1 plus 10, 11. Okay, now what if our n equals to 10,000? So then it is going to be 1 plus 10,000. Okay, so you can see that this constant value is not going to be significant in terms of the input size. So our runtime actually is going to change significantly depending on the input size. Okay, depending on the value of n. So here in this algorithm, the time required for this algorithm is proportional to n. All right. So the value of the constant, it doesn't matter how large the value of the constant is, it doesn't matter. So the time required, the total cost is going to depend significantly on the value of n, or we can say the value of input size. Okay. So here if n is like 100K, all right, 100K or millions. Depending on that, our input size, our runtime is going to depend on the value of n. All right. So here is we have another example, nested loop. Okay. So nested loop means we'll have a outer loop, and inside this outer loop we can have another loop. Okay, and that's how actually we can have multiple nesting. So inside one loop we can have another loop, and that's how we can have 2 level, 3 level, 4 level, 4 levels of loop. All right, but what happens? Okay, what happens if we have a nested loop? And we're going to see how to calculate the runtime of the algorithm. All right. All right, so let's see here. These are simple set of instruction. So it is going to run, these 2 lines is going to run only 1 times. So here we have the outer loop. Okay, so this loop has this statement will be executed. Cost is C3, but this is going to run n plus 1 time. All right, now inside this loop we have this body. Okay, everything here is going to run n times. All right, all right, but what happens when we are going to see another loop? All right, so this loop here we are having another inner loop. Now this loop is going to run n times n plus 1 times. All right, so because here we're entering in another loop. All right, another loop. So this statement will be executed. So inside one iteration, okay, for one iteration this will be executed n plus 1 times. Now as there are n iteration, so the total runtime, the total number of iteration here for this one is going to be n times n plus 1. Okay, and it will be it will run n times n time, and it will run n times n time. Okay, so now let's see what will be the total runtime. Okay, so C1 plus C2, it will be executed n plus 1, it is n. Then C5 will be n times n plus 1, C6 n times n, C7 n times n, and then this one is only n times. Then you can see that it will be proportional to n square. All right, so you can see that here if our n value equals to 10, all right, so the total number of iteration is going to be like around proportional to n square. Okay, so let's actually if we simplify this statement, okay, if we simplify this statement, we're going to find something like that. Let's see. All right, let's see, Pn square plus Qn plus B. Okay, where P, Q, B all are constant. All right, so and after we simplify this whole equation, we'll see the total cost is going to look like something like that. Okay, so here P is constant, Q is constant, and B is another constant. Okay, and N is the input size. So if our input size is 10, here total cost will be like, and let's see, for each of the constant value we're assuming the value are 1. Okay, so then in that case the total cost will be 10 square plus 10 plus 1. Okay, but if n equals to 10,000, so you can see that total square plus 10,000 plus 1. Okay, so this constant value PQ, it doesn't matter, PQ and P, it doesn't matter how large the value is, okay, our runtime actually is going to change significantly depending on the input size. Okay, and here you can see actually what is the difference here. Okay, how our total cost is going to increase if our n value, if our input is increasing in this case. All right, here the time required for this algorithm is proportional to n square. So let's see actually the general rules how we can estimate the runtime. So if we have loop, okay, if we have just a simple loop, then the runtime of the loop is at most runtime of the statements inside of the loop times the number of iteration. All right, so if we have a loop like for I equals to 1 to n, all right, something happens inside this loop. All right, so in that case the runtime of the loop is at most runtime of the statement inside the loop times the number of iteration. Okay, so the runtime of this statement times this number of iteration. All right, so let's say this body takes c1 times, and here we have iteration, okay, n iteration. So the runtime will be c1 times n, means proportional to n. Now if we have a nested loop, so in that case runtime of a nested loop containing a statement in the innermost loop is the running time of the statement multiplied by the product of the size of all loops. Okay, if we have something like I equals to and inside that we have for j equals to 1 to n. All right, so you can see that here runtime will be proportional to n square. All right, because everything here will be executed n times, but here they will be executed n square times. All right, now if we have consecutive statement, so consecutive statements, we're going to just add the runtimes of those consecutive statement. So we have statement 1, we have statement 2. All right, so it has a runtime like say n square, it has a runtime like n. Okay, and we have statement 3 and it has a runtime c1. So what actually we're going to do, we're going to add all of them. All right, so if else is never more than the runtime of the test. Okay, the test means the if condition plus the larger of runtime of s1 s2. All right, so if statement means we have two branch s1 s2. All right, and here we have the condition means the decision. Okay, so runtime of the decision, and then okay, either this one or this one will be executed. So it will never more than runtime of the test plus the larger of runtime of s1 and s2. Okay,